Hi, this is Lindsay Beagle, and today I'm going to talk about the role of the pancreas and liver in regulating digestion. So, chemical digestion involves accessory organs. Chemical digestion in the small intestine has three accessory organs. Today, I will focus on the pancreas and the liver, although the gallbladder will be mentioned in the future. The pancreas is here and involved in the pancreatic juice, which has enzymes in the bicarbonate ion. The liver produces bile and exports to the duodenum, and the gallbladder is important in storing, concentrating, and releasing the actual releaser of bile to the duodenum from the liver. So let's take a look at the pancreas before we go into the liver. So the pancreas itself sits at the back of the abdomen, triangular shape, about 6 inches long, and is behind the stomach. The head of the pancreas sits along the small intestine, this first part of the small intestine, and actually joins in with the duodenum via the pancreatic duct. So this allows the pancreatic juice that's made by the pancreas to enter the duodenum, and so food that's coming from the stomach and the chyme that's made enters this first part of the intestine, and the enzymes made by the pancreas and the bicarbonate ion made by the pancreas can be met. The food can be met by those things via the pancreatic duct. So before we get into those enzymes and what's occurring there, let's just take a look at what happens when we eat and the things that we're trying to digest. So we have starches and proteins and fats, and when we eat something, the salivary glands that we have are already producing that amylase and breaking down those starches. And then when we get into the stomach, we have enzymes there that are breaking down some of those proteins and things. But nothing has really been done yet with the fat. But by the time we get to that small intestine, we have some broken down bits of starches and proteins, and our fats are still pretty intact. So this is somewhat of a busy slide, but I think sorry, I wanted to make sure you could see the whole slide. So let's talk about what's in the pancreatic juice, and each step of this leads really to the breakdown of all the major nutrients, which can be done by the pancreas, which makes the pancreas a pretty important gland. So first we have the bicarbonate, and this bicarbonate ion is important because when we have over here, when you have your pancreas and you have this food coming into the duodenum and this first part of the small intestine, it's coming from the stomach, which is a pretty harsh environment. And when we get here, this bicarbonate ion that's made by the pancreas, or released by the pancreas, really allows this to become a more alkaline solution, which is good since it allows for enzymes to work a little bit more easily than having to adapt to the harsh environment of the stomach. So this bicarbonate ion is down. If you look at this diagram down here, without having to make a million slides, I kind of tried to put it all in one. This diagram is neat because it shows the cells that produce the bicarbonate ion have these high concentrations of carbonic anhydrase, and you have chloride that's entering the cell by indirect active transport, and it leaves on the apical side through a CFTR channel, and then re-enters in exchange for this bicarbonate ion. Again, this bicarbonate allows for this environment to become more alkaline. And if we go into looking at the pancreas, again, it breaks down all the major nutrients, and glands are usually one or the other. You have exocrine glands that work through secretion of ducts, or you have endocrine glands that work by secreting into the bloodstream, and the pancreas happens to be both. So we have this exocrine gland, acts as an exocrine gland because it secretes digestive juices through the pancreatic duct, again, into the duodenum, and it also acts as an endocrine gland because it produces and secretes hormones, insulin and glucagon, into the bloodstream that control blood sugar. But today we're going to look at the exocrine part of this and what these pancreatic juices do. So in this pancreatic juice we have enzymes, and there is a whole slew of different enzymes, and over here shows a little bit of the activation, but we have enzymes coming from pancreatic amylase, which, if you remember, we had those starches that were being broken down already by the salivary glands that are now even further broken down by that amylase. The amylase is breaking it down even more in the pancreas. And then we have enzymes like trypsin and chymotrypsin and carboxypeptidase, which take proteins and more or less break apart those peptide bonds. So we're already working on things that may have been broken down a little bit in the salivary glands or the stomach, but one of the things that we're working with then that hasn't been broken down, again, is fat. So we have this pancreatic lipase that is going to try to work on these large droplets of fat that nothing has really occurred with them through the parts of digestion that they've been through. So this is where the liver comes in, because we kind of need the bile that will help us, and I'll show you how that will help. So everything's kind of working together to break down all of these major nutrients in chemical digestion in the small intestine. So here we have the liver. It is the largest gland in the body. It sits inferior to the diaphragm in the upper right quadrant. There are two lobes to the liver. You have the right lobe and the left lobe, and in this right lobe we have also a quadrate lobe and a posterior quadrate lobe. Now we also here have the porta hepatis, and your porta hepatis is where the hepatic artery and the hepatic portal vein enter the liver. And the hepatic artery delivers oxygenated blood from the heart to the liver, and the hepatic portal vein delivers partially deoxygenated blood containing nutrients absorbed from the small intestine, and actually supplies much of the oxygen to the liver. In addition to nutrients, drugs and toxins are also absorbed. But here we are looking at the production of bile. So the liver itself produces bile through hepatocytes, and bile is an aqueous solution that's produced and secreted by the liver. It contains bile salts, phospholipids, cholesterol, bilirubin, water, and electrolytes. And what happens here is we have these the bile that's produced in the hepatocytes that finds its way through various network of ducts and eventually leaves the liver via the hepatic duct and the common hepatic duct, and goes into the gallbladder. And when the gallbladder is stimulated by the release of the CCK hormone, what it's going to do is in the gallbladder, this bile has been concentrated and stored. This bile that has been produced by the liver has been concentrated and stored. And the bile will then leave via the cystic duct and eventually into the common bile duct, and also find its way into the duodenum. So what does the bile do once it's here? We have things being broken down by protein, peptidase, you know, um, enzymes and amylases and things like that. But we have that fat that I had talked about that is kind of tough to be broken down. So we have this emulsification of fat in digestion, and it really is a nice combination of having the bile that's produced by the liver and the pancreas, the lipase that is produced by the pancreas come together to break down these fats. So basically you have this fat globule that, if left to itself, these fat molecules would just aggregate to form these large globules that would have only a small surface area, that really only water-soluble lipases would be able to act. So bile prevents this from happening. The bile, what you have is you have a hydrophobic end. This bile salt has a hydrophobic end and a hydrophilic end. And what happens is the hydrophobic end, which is absorbed here by the fat droplet, and the hydrophilic end sticks out. And what this does is the hydrophilic end prevents the fat droplets from aggregating all together into one big fat droplet, and this increases the whole surface area. And because the surface area is now increasing, these are smaller emulsified fat droplets, that pancreatic lipase can come in and break down the fat. So you basically see lipases working to break down the fats and the fatty acids and monoglycerides, and then those products are lipid soluble and can pass through the plasma membrane. And so you have your pancreas working together with your liver in the digestion of all your nutrients. And that is my presentation.